Good afternoon, everybody. It's my pleasure to welcome you online today to EPA Victoria's second environmental seminar series of 2021, focused on climate change and environmental public health, with special guest speakers Matthew Riley and Dr. Angie Bone. I am Dr. Carolyn Brumley, Victoria's Acting Chief Environmental Scientist at the Environment Protection Authority. I would like to begin by acknowledging the Aboriginal people as the first peoples and traditional custodians of the land and water on which we live, work and depend. We pay respect to Aboriginal elders past, present and emerging. As Victoria's environmental regulator, we pay respect to how country has been protected and cared for by Aboriginal people over many tens of thousands of years. We recognise the unique spiritual and cultural significance of land, water and all that is in the environment, and the continuing connection and aspirations for country of Aboriginal people and traditional custodians. A few notes on this live stream event. Please be patient with any technical difficulties. The structure of today's event will feature an introduction by myself, a presentation by our guest speakers, time for Q&A, and a conclusion. This event will be recorded, so if you need to leave early or miss parts of this session, you can watch it again later via EPA's website. This session has live closed captions to ensure that it is accessible for all. We will open the Q&A now, but we'll respond to questions after the presentations. Please provide your questions at the icon with the question mark on your screen. We will try to get to as many as we can, and all questions not answered today will be responded to via email. Please provide your contact details so that we can respond to you. Today, we are here to talk about climate change and its effects on environmental public health. A changing climate impacts the environment around us in multiple ways. Directly via heat waves and extreme weather events such as storms, forest fires, floods and drought, and indirectly via decreasing air quality, effects on ecosystems, risks to recreational water quality, biodiversity losses and changing patterns of disease. Climate change also affects us indirectly via impacts to our economies and social structures due to events such as mass migration and conflict. While the magnitude and nature of health impacts from a changing climate are hard to predict with precision, there is clear evidence of links to respiratory disease, cardiovascular disease, infectious diseases, mental illness, injury, undernutrition and allergies. Over the last 100 years, Victoria's average temperature has increased. The frequency of unusually hot days in summer and very high fire danger days in spring has increased, and winter rainfall has fallen. In the past decade, we have witnessed significant events in Australia, including a decline in broadacre farm profits over the last 20 years, which are estimated to be 37% below those if earlier climate conditions had persisted. The 2019-2020 bushfires, smoke-related health costs from this event were an estimated $486 million. Heat waves, these are estimated to cost the Victorian economy an average of $87 million per year. And the 2010-2011 Victorian floods, these were estimated to have cost $1.3 billion. In the coming decades, we are likely to experience worsening heat waves and harsher bushfire seasons because of this changing climate. This is in addition to increases in planned burns to mitigate the impacts of potential bushfire events. A recent study conservatively estimated the state would incur damage costs of about $1 trillion by 2100 if no further global action was taken in relation to climate change. The interconnected nature of climate systems, ecosystems and society means that none of us are immune. Minimising and reducing the impacts of a changing climate is challenging and requires a multifaceted approach and multidimensional strategies and initiatives. While this can be complex, we all have a role to play. Action to reduce greenhouse gas or GHG emissions can produce major health co-benefits. For example, constructing energy efficient homes improves livability and reduces the harmful health effects of extreme weather events. Uptake of renewable energy and electric vehicles can deliver significant human health benefits through reductions in local air pollution. Air pollutants from fossil fuel combustion, particularly from coal-fired electricity generation and internal combustion engines in motor vehicles, produce air pollutants associated with cardiovascular and respiratory diseases. the transport-related benefits associated with electric vehicles are projected to increase substantially over time. Planting vegetation for agroforestry removes carbon dioxide from the atmosphere and can help restore natural landscapes. And improved cycling and walking infrastructure reduces vehicle emissions and helps us all maintain more active and healthy lifestyles. In Australia, Victoria takes the lead in reducing the impacts of climate change and is the first Australian state and one of the first jurisdictions in the world to legislate net zero emissions by 2050. As the state's environmental regulator, EPA is an advocate for effective action, and there is plenty underway, particularly in GHG emissions and health. EPA supports implementation of the Victorian Government's direction on climate change, including delivering Victoria's climate change strategy, just released this month. The strategy commits to interim targets to reduce emissions by 28 to 33% by 2025 and by 45 to 50% by the year 2030. Advances in technology, including transitioning the transport sector to zero-emission vehicles and hydrogen power, reducing emissions in our agriculture sector, including helping farmers to store carbon via the Victorian Carbon Farming Program, and transitioning government operations such as schools, hospitals, police stations and metro trains to be powered with 100% renewable electricity by 2025. This is an Australian first. EPA continues to consider climate change in its decision-making by ensuring best practice design of new facilities and adopting a risk prevention approach to environmental hazards. One of the cornerstones of the EPA's new Environment Protection Act is a general environmental duty, which requires activities that present a risk of pollution to be proactively managed as far as reasonably practicable. This applies to GHG emissions. EPA is developing GHG emission guidance to support business and government bodies understand and manage greenhouse gas under the new laws. The guide will raise awareness of the harms from GHG emissions and ways to eliminate or reduce those risks. A consultation draft is expected to be available in late 2021, this year. EPA's new legislation will also be supported by a forthcoming guideline for assessing and minimising air pollution in Victoria. This will help businesses to understand, assess and minimise the risks from their air emissions. The guideline will provide a framework for assessing risks to the environment and human health from air emissions, new air quality assessment criteria, which replace the design criteria in the State Environment Protection Policy for Air Quality Management, or the SEP-AQM, and guidance on how to minimise air emissions and manage any remaining risks. EPA will release the draft guideline for public consultation on the Engage Victoria website soon. EPA has also led a review of air quality standards for ozone, nitrogen dioxide and sulphur dioxide that are established in the National Environment Protection Ambient Air Quality Measure, or the AAQ-NEPM. The review accounts for evidence of the health effects of these pollutants and will be considered for adoption as reference standards in Victoria after the new Environment Protection Act commences on 1 July 2021. EPA also shares important warnings, data and air quality information on our website, AirWatch, so that community has access to data and public health advice. At the peak of the 2019-2020 bushfires, we had almost 500,000 views on EPA AirWatch a day. For example, on the 14th of January 2021, there were 459,940 views, and on the 15th of January, there were 368,558 views of our AirWatch site. Talking about this environmental and public health problem is key to creating positive change. And on that note, it's with great pleasure that I introduce our guest speakers. Matthew Riley is the Director of Climate and Atmospheric Science at the New South Wales Department of Planning, Industry and Environment. Matthew has delivered multi-million-dollar programs in climate change impacts and adaptation, greenhouse gas emissions, air pollution, and an energy and energy efficiency policy that has led to significant benefits for New South Wales. Matthew leads a team of skilled climate and atmospheric researchers, technicians, programmers and data analysts that manage the largest and most comprehensive air quality monitoring network in Australia. Matthew is the current chair of the National Air Technical Advisory Group Chair of the Cross-Jurisdictional Community of Practice on Climate Change, a Fellow of the Australian Institute of Energy, and is on the advisory boards of the ARC Centre of Excellence in Climate Extremes and the National Environmental Science Program's Clean Air and Urban Landscapes Hub. So a very busy guy. We're very lucky to have him today. Dr. Angie Bone is the Deputy Chief Health Officer Environment at the Victorian Department of Health. Angie provides expert clinical and scientific advice and leadership on environmental public health issues. She supports the Chief Health Officer and staff within the Health Protection Branch. Angie has extensive experience and clinical expertise in public health. She is a medical doctor with experience in health protection related to environmental hazards and infectious diseases in the UK and several other countries. Angie has a keen interest in the social and environmental determinants of health, particularly climate change, extreme weather events, housing and urban planning, and infectious diseases. Angie is a Fellow of the Faculty of Public Health UK, a member of the Royal College of Physicians UK, an Associate Clinical Professor at the University of Exeter UK. She holds numerous qualifications in public health and tropical medicine. We're also very lucky to have Angie here today. Thank you to Matthew and Angie for joining us on this important topic. I will now hand over to Matt to continue today's session.
Thank you very much, Carolyn. And thank you to EPA Victoria for inviting me to speak to you today a little about the work that we're doing in New South Wales and sharing our thoughts and some of the challenges, some of the things that we've learned about tackling climate change and indeed looking at climate change through that perspective of human health. I actually think that we should reframe climate change as fundamentally a human health issue, not an environmental issue. It is the core of what we do today in the environment space, but also in the planning space, in our infrastructure space, and indeed in our emergency services and response space. I think that climate change is a human health issue, and that's what we should be, how we should be looking at it. Before I go further, what I wanted to do was I wanted to acknowledge the traditional owners of the lands on which we meet. Wugul Ora, Wugul Kowing, Wugul Bemul, Wugul Garagarang, Wugul Marimuchan. One people, one sun, one ocean, one earth, one big family. And I'd just like to reflect that now at a time when we think about resilience in the context of Black Summer, in the context of COVID, of the floods, those disasters that Carolyn spoke about in her introduction, I often reflect on the resilience that the traditional owners of the lands that we meet on, that we live on, that we play on, the resilience that they've shown over many tens of thousands of years. And I truly pay my respect to them and indeed all First Nations people who are joining us today. The overview today for my presentation, what I'm going to do is I'm going to go through and give you a little bit of a climate change 101, just touching on climate modelling and giving a little bit of a global perspective. I think that most people here today will understand the drivers of climate change and be aware of the changes that we're already seeing. From there, we're going to focus in a little bit more on regional changes, regional climate and how that's changed over the past century or more, and indeed how we model potential future changes in climate. We'll also look at the impacts of those changes in climate, because indeed the reason we are interested in the weather, the reason we are interested in climate is because it affects us. It affects us in so many of the things that we do and so many of our day-to-day activities. I often reflect on the fact that when I have discussions about climate science or indeed about air pollution, that it's one of those sciences that we're quite lucky to be presented with every single day of the year. No matter where you are, you'll have some insight into what's happening with the weather of the day or indeed the climate. We're given science through our daily weather presentations every single day of the year. And as a consequence, people understand a little bit of what's happening, but they also need to understand a little bit more about the framing of what's happening so that they can relate that to their own personal framing. And that's something that we try and do in New South Wales. But also it can be a limiting factor as well, because we tend to think of weather as this sole thing. We tend to think of climate as this sole thing and climate change as this sole thing. When we think of solutions, we often think just within a certain sector or just within a certain framing or perspective. That may be infrastructure management, or it may be the provision of emergency management services, or indeed it may be the provision of health services. I think one of the things that we must do as we move towards net zero emissions and we try to build resilience is we need to think of climate change as that truly cross-cutting issue that it is. It impacts us on many levels and it impacts us on a day-to-day basis, and it's not the future. Climate change is now. So I'll finish off by talking a little bit about how we're trying to integrate some of those perspectives into the approaches that we're taking to tackle climate change, both from a mitigation and an adaptation perspective in our effort to build resilience in New South Wales. And then I know that after my presentation, Dr. Angie Bone will give you a really good insight into the health focus of climate change in EPA. So moving on, what I'd like to do is I'd like to just give you a quick overview. As I said, most of us know what climate change is. It is those long-term changes in climate that occur over decades, centuries, or longer. What we're experiencing now is caused mainly by increasing greenhouse gases in the atmosphere. And that is primarily a result of burning fossil fuels. Those heat-trapping gases are warming the earth and oceans and are causing sea level rise. Changes in storm patterns, altered ocean currents, changes in rainfall, more extreme heat events, fires and drought. And of course, those changes in climate impact us, and they impact us in many different ways. Intensifying heat waves affect human health and also infrastructure. Changes in rainfall and temperature affect forests, agriculture, affect their productivity. And it also has impacts on freshwater supplies, on our coastal ecosystems, and indeed on marine ecosystems. This graph here shows you close to 1 million years of CO2 in the atmosphere, constructed from a range of ice cores. And you can see how much CO2 has risen in the atmosphere over the past 50 years. So how fast is the climate changing? Well, we know from multiple evidence bases, multiple approaches, multiple attempts at filling in the gaps of our observations and looking at how temperature has changed across the globe, that we can safely assume that temperature has risen by 1 degree Celsius since the late 19th century. And we can see that rapid increase in temperatures, in particular from the 1950s onwards. And at the same time, we commenced detailed CO2 measurements at places such as Mauna Loa in Hawaii, but also at Cape Grim in Tasmania. And we can see that steady march forward of CO2 levels. So we see that the temperature has changed at the global level. But temperature changes and climate changes do not happen uniformly in space or uniformly in time. We see interannual variation. We see variations that are a consequence of El Nino and La Nina, or other weather systems, other climate patterns, other climate systems. But we also see local regional variations. And this leads to less homogeneity in the way that we see climate change manifest. And if we look here at Australia, and this is from the most recent State of the Environment report, we can see that temperatures in Australia have risen steadily over the past 40 to 50 years. And indeed, I always find this interesting when we look at this graph to focus on these El Nino events. So not only are average years increasing in temperature, but each of the El Ninos are increasing in their peak of temperature as well. Something that's particularly important to Victoria is changes in seasonal rainfall. And again, this is that idea that we don't see constant changes in the climate when we're looking at climate change. We see changes in seasonality, we see changes in daily patterns, and we also see changes across different regions. And this is the change in rainfall that we've seen across southeastern Australia. And in particular, if you focus on the last 2 decades, you'll see that significant reduction in rainfall, far fewer wet years and far more dry years. As I mentioned, we know that anthropogenic pollution and primarily CO2 through the burning of fossil fuels is the major cause of this climate change. And we can see that by using our models. We can have a look at the modelling system here, and we can look at what we model at the Earth, the whole globe level, at the Earth system level. And we can look at what changes we would expect if we took away the influences of the anthropogenic sources of greenhouse gas emissions. If we went back to took away the greenhouse gas emissions from all of our combustion activities, all of the fossil fuels, and we look at remove the changes in land cover and also aerosols. And what we can see is that green line there, which is the climate we would have expected if we'd only had the natural drivers during this time. But indeed, what we see is the observed changes in the black and the change caused by the human drivers in the red. And that is the clear data that leads the IPCC to their firm conclusion that almost all of the change in climate that we've observed over the last few decades is due to anthropogenic influences. So I'm just going to touch a little bit on global climate modelling, because I think we're all aware of the importance of global climate models to our understanding of the climate and our understanding of how the climate may change in future. I've heard some modelers suggest that Earth system modelling, so modelling the entire Earth system using our global climate models and our carbon system models, is one of the peak intellectual undertakings of humankind. And I actually agree with them a little bit. It's quite a huge task to understand the Earth system as well as we do. Now, there are still uncertainties, and I'll touch on them later. But then to be able to model that within a computer by breaking the world up into a whole bunch of smaller and smaller grids, and then within each of those grids, looking at each of the different physical processes that occur, and then being able to model that through the system and really be able to replicate quite well in many instances how the Earth system works, how our climate works. And this is because at its core, Earth system modelling and global climate models are based on fundamental laws of physics, of fluid motion and fluid dynamics, and of chemistry. They're massive undertakings, somewhere in the order of 1 million plus lines of code. They must run on the largest supercomputers that there are, and they take a lot of time to run. I'll talk a little bit more about that when we think about regional modelling as well. But I think it's pretty amazing that we can code up into a system of binary bits models that can effectively, out of the way that they operate, show us how winds, how temperature, how radiation, how humidity, how surface waters, and how our oceans will change over time. And I actually do believe this is one of the great undertakings of mankind, to be able to model our Earth system as well as we do. And we use those global climate models to model a range of different scenarios to give us an indication of what the future climate might be. So not only do we look back in time, not only do we use the global climate models to, for instance, assist us with weather forecasting at the moment and through numerical weather modelling and numerical weather prediction models and real-time Earth system models, but we look at how changes in emissions, changes in energy use, changes in population may affect that global climate in the future. And so what I've put up here is a couple of indications of how we may see changes in the future. The first one is the global model, and it's an ensemble of the models from AR5 using what's called the Representative Concentration Pathway, or RCP 2.6. And think of this as almost a best case possible outcome. It is the scenario that gets us closest to our Paris commitments. And we can see, even with that, looking at towards the end of the century, we still see some significant increases in temperature in parts of the globe. But global temperatures do get us near the Paris commitments. Down on the bottom, we see RCP 8.5. And this is often thought of as towards a worst case scenario. And you can see significant increases in temperature across the globe, increases of up to 12 degrees Celsius in the northern latitudes. And that's quite a sizable change. Now, just a note on global climate models, there is not one perfect model. There's not one model that we can run that lets us understand with great precision and accuracy what the future climate would be. What there are there families of models, there's ensembles of models, there's some models who do some things quite well. There are some models that do other things not so well. But what we've learned from assessing models and how well they perform is there is not one model that does everything well. So hence what we do is we look at ensembles of models. We look at and we assess those models to see from all global climate models is fairly strong agreement in warming across different regions of the world and in the variation of the magnitude of warming across different regions. But what we don't get is we don't get agreement across all models about what the magnitude of warming will be in individual locations for individual scenarios. But we do get that understanding from ensembles about the likely trajectory that we will see. And temperature is going in one direction and one direction only, and that is up. So, as I mentioned, GCMs, global climate models, do a good job of simulating the Earth's climate, but they are not perfect. Because they have to model so many different physical processes, because there has to be so much information stored and put through the system, there are trade-offs. We can't run global models at the very finest scales and resolutions. That means that things such as the Great Dividing Range are not well represented in global climate models. And hence, things that may be important in local and regional areas, such as rainfall that occurs from a flow of air across a mountain range, or indeed the impacts of the coasts, are not well reflected in GCMs. Also, we do know that GCMs need improvements in the way that they handle clouds. And this is a function of how the GCMs are put together. And here on the right, there's two types of clouds that are in there. The first one, cumulonimbus cloud. And what happens with these convective events, with these storm events, is these occur within a grid of the model. And think about that horizontal grid of the model, which may be a couple of 100 kilometres in resolution. And these are storms that are a few kilometres in width. So they're represented within that grid. They become what we're called as subgrid processes, and they're parameterized in the models. So there necessarily needs to be some simplification of how how these mechanisms are coded into the models and how they resolve themselves in the models. And cumulonimbus or storming weather, they're subgrid scale in the horizontal, but they aren't subgrid scale in the vertical. They have strong vertical extent. And many of the processes that occur within the grid are transferred through the vertical grids. That's very different to some of the other clouds that we see. And here's some picture of some nice cirrus clouds, but we could put up some marine stratocumulus clouds as well. And these are clouds that don't have great vertical extent, but they have great horizontal extent. And we can simulate those in our Earth system models reasonably well in the horizontal, but not so well in the vertical. So these are subgrid scale processes in the vertical, not in the horizontal. And we know, and the research community knows, that we need to have better cloud simulation. We need to improve the way that we reflect clouds within our modelling systems. And that can come about in a couple of different ways, from improved parameterizations, so getting those processes right within the modelling systems, but also by running at finer and finer resolution, either within the global climate model or within regional climate models. And there's a lot of work going on to improve the simulation of clouds in Earth system models. So that brings me on to GCM errors. And you will hear a lot of discussion about the fact that models are wrong and models have errors and models have biases, and indeed they do. But given what they have to do and how well they do what they have to do, regardless of these biases and errors, then they do a very, very good job at simulating the global climate, at simulating changes across very large regions, at getting a better understanding of some of the large drivers of our climate system. But as you can see here and here, the different colours represent different biases in temperature. And you can see that not only is there not one model that does everything well, there's not one model that does everything well at all places across the globe. And indeed, there's few models that do some things well at all places across the globe. So there's some biases that are inherent in the global climate models. We think of them perhaps as errors, but really they're just a presentation of some of the simplifications that have had to take place within the modelling system to ensure that we can model the Earth system as a whole. But what I wanted to do here is just focus on Australia as an example, because at the global level, we can see some changes in Australia represented by global climate models. And we see some biases, and some of the biases are in different directions. So that gives us some information about direction of change or the likely magnitude of change when we bring multiple global climate models or Earth system models together. But it doesn't really give us a great deal of information about the regional change. And I'll come to that in just a moment. So giving us a little bit of an overview and some takeaway thoughts on these changes, we know that the climate is changing faster and faster than it has in the past 800,000 years. And indeed, CO2 levels are higher than they've ever been over the past 800,000 to 1 million years. And that change in CO2 levels is the primary driver of the change in climate. And that is because of human activity. I'll talk a little bit about some climate extremes. We understand a little bit more about global climate models and how they might help us to understand the past, but also understand the future, plausible futures. I'm now going to talk a little bit about regional climate models to help us understand what's happening to local climate. Before I get into that, I'm just going to talk a little bit about the changes in the local environment. So as I mentioned earlier, we already know that the globe has warmed by about 1 degree since pre-industrial times or the late 19th century. In Victoria, we've actually seen about 1 degree of temperature increase since about the 1950s, some rapid warming. And if I go down using Bureau of Meteorology ACORNSAT data, so the high quality temperature record maintained by the Bureau of Meteorology, we can see those changes come through. And this is reflective of the data that I presented earlier from the State of the Climate report. But just to note, the hottest decade we've seen over this 110-year record has been the most recent decade. And it is 1 degree hotter than what we saw for the baseline period between 1960 and 1990. What does it mean for Victoria? What changes have we seen in Victoria? Similarly, if we look at changes in Victoria, we see that we've had some significant increases over the past 20 or so years. And I'd like to reflect at this point in time on what that means for an individual. If you were born in Victoria after 1996, you have not lived a year of your life in a climate that was below average temperature. So people now who are actually finishing their PhDs, they've finished their high school or tertiary education, they've moved into the workforce, they have not lived a year in Victoria where temperatures were below average, which is quite extraordinary. The hottest decade in Victoria, again, the past 10 years, about 0.9 degrees Celsius above the 1961 to 1990 average. And again, 1996, the last year that was below average temperatures in Victoria. But of course, if we go down to a little bit finer detail, this is data from Melbourne, from the ACORNSAT data from Melbourne. And we see a similar story here in Melbourne. But what we do see if we go between them is a slight variation. And I wanted to just go up and down between the continental scale change, the change across Victoria, and the change that we see in Melbourne. And you'll see some changes in magnitude and also some local variation. And that's because climate does vary on finer regional, spatial scales. If we look at rainfall, it tells us a slightly different story. Not that steady increase, march up and down, but a great deal of variability across Victoria, indeed across southeastern Australia. And again, pointing out that change that we've seen over the past 20 years with significantly more dry years compared to wet years. But if we look down at the maps on the bottom, what we can see is that change and that regional variation in change. This is not uniform across the state. And there are some areas that have seen greater levels of drying than other areas. So again, reflecting that importance of having local information available to help us understand climate and how it's changed. We often look at averages, and we did look at average rainfall there, but of course it's changed over that period of time. It's how that rainfall has changed. And this is where we look at some of those extremes. We know that as temperatures increase, there is a higher availability of the atmosphere to hold more water. And conceptually, we think that that will lead to different characteristics in rainfall, heavier rainfall or stronger rainfall events when they occur. And indeed, when we look at what we've seen across New South Wales and Victoria over the past century, is we see some significant changes. And these are measures of changes in rainfall characteristics. The top left-hand corner is the Simple Precipitation Intensity Index, or SDII. And this is quite simply the total amount of rain each year divided by the number of rainy days. And we say a rainy day is a day where there's more than 1 millimetre of rain that's fallen. The little stippling, the dots across the map, show us areas that are statistically significant trends. So we can see that there's been change in precipitation intensity over the past period. We also see that there's been a change in the number of consecutive dry days, which is the top right. And this is the length of days in between one wet day, so a millimetre of rain, and the next wet day, another millimetre of rain. And you can see in particular in Victoria, areas where we've seen statistically significant changes in that trend. And we see that as well in consecutive wet days, which is the bottom right-hand corner. And again, that's the time period between a day where we've had 1 millimetre of rain and the next day that we have 1 millimetre of rain. And the next day where we don't have 1 millimetre of rain. And what you can see here are some statistically significant changes in the number of consecutive wet days, and increasing and decreasing numbers of consecutive wet days. And so this is over the period of a century or so. If we look at those changes in the Mallee, in northwestern Victoria, statistically significant changes of somewhere in the order of 1.5 to 2 days shorter between consecutive wet days. And that's quite a significant change. So what that means is that the rainfall that we are seeing is happening less frequently, and it's happening over a shorter period of time. And then this final precipitation extreme that I wanted to show you was the wettest day of the year. And again, looking at how that heaviest downfall of the year occurs. And again, what we see across much of southeastern Australia is significant changes in the wettest day of the year. And this agrees with what we expect conceptually, that a warmer atmosphere holds more water, and hence there's more water available to be precipitated out, to be rained out when it does rain. And I wanted to show these indices for you to give you an understanding that we don't just look at things such as the change in rainfall, in total rainfall, or indeed just the change in seasonal rainfall. We do look closely at how the rainfall's changed and the different types of or characteristics of rainfall, because they mean different things for different people. Consecutive wet days is very important because that helps us understand the amount of rain that will fall over a period. There's a certain capacity that's available, not just in the natural drainage systems, but in our anthropogenic, in our human drainage systems, in our towns and our cities. And it gives us an idea of the capacity of those systems to be able to handle wet conditions. Similarly, things such as consecutive dry days gives us an understanding of the amount of evaporation that might occur in between periods of rainfall. So I wanted to use this just to highlight some of the indices that we look at to help us understand how climate is changing. Now, of course, that was talking about climate change that we've witnessed over the past, but many of us, and indeed for our decision makers, we want to understand about climate change in the future. So I'm just going to talk a little bit before I present data about regional climate modelling. This is an example of our model setup, which is NARCLIN, the New South Wales and ACT Regional Climate Modelling Project, and we also have South Australia as a partner now. And we've run models at different resolutions across all of Australia. And I wanted to note, just focusing on the bottom four maps there, the difference in scales that we see. Observations, which is on the left, and this is from the Australian Gridded Climate Data, or AWAP data, if you're looking at older data, and this is gridded out at about 5 kilometres resolution. But note that this is really modelled observations, because we don't observe everywhere. We have a sparse network of monitors in reality, a very good network, a very strong network, but we can't monitor everywhere. So what we do is we take observations, the Bureau of Meteorology takes observations and then applies methodologies to provide spatial maps of the likely observed rainfall based on the rainfall of our observations. If we move to the global climate models and we look at this global climate model at 200 kilometres resolution, and that's the second from the left, and you can see that we don't really see any influence of the Great Dividing Range. You can see it in the observations, but you can't see it in the GCM. And this is because really for the GCM, the Great Dividing Range doesn't really exist. It's smoothed out. It's not 1,000+ metres elevation. It's much less than that, generally tens of metres of elevation. And that's how it's represented in the global climate model. And also with this global climate model, you don't really see the influence of the coast. And I'll come back to that in a second. So what we do when we model is we model at intermediate steps. We take the global climate model, and then we run it through a regional model. And the first step of our regional model is at 50 kilometres resolution. So taking these models at 200 kilometres resolution and then stepping them down to 50 kilometres resolution. And again, you can start to see the Great Dividing Range be reflected and the impacts of that orographic rainfall be reflected in our data. Here, you can't see the orographic rainfall in the global climate model. Here at 50 kilometres resolution, which still seems like quite a lot, quite a coarse resolution, but we do start to see the impacts of the Great Dividing Range and indeed orographic rainfall in the southeast. Just noting at that 50 kilometre resolution, we model not only all of Australia, but most of Indonesia, Papua New Guinea, and also New Zealand and the Pacific. And that's important because they have influences over our climate. It also aligns with international efforts through the CORDEX, the Coordinated Regional Downscaling Experiment, to do this modelling in a coordinated manner across the globe. So going back to our model representation, we can see that when we go from 50 kilometres resolution to 10 kilometres resolution, we actually start to see in some fine detail the Great Dividing Range and the impacts of the Great Dividing Range on rainfall. And indeed, modelling at finer resolutions gives you more resolution of the Great Dividing Range and its impacts on orographic rainfall. This is our modelling system at 10 kilometres resolution. In Victoria, you're very lucky to have the VCP 19, Victoria Climate Projections 19 modelling, which models all of Victoria at 5 kilometres resolution, giving you even a little bit more detail. And that's available from the DELP website. I want to go back to a couple of things that are of particular interest about regional climate models. So looking at rainfall here and the resolution that we get from orographic features as we move to finer scales. It's equally important, if not more so, when we're looking at coastal areas and indeed coastal cities to understand changes in temperature, moving from global climate models down to regional climate models. This is one of our global climate models at 150 kilometres resolution, the CCSM model. And you'll note here that this is the coast. It doesn't really see the coast, and its representation of the coast is pretty much a straight line. It certainly doesn't see Sydney or Newcastle. It's the information for those urban heat islands from the local climatology there is just not within the global climate model. However, when we run it through that step change, going through a 50 kilometre model down to a 10 kilometre model, or indeed in Victoria, your 5 kilometre model, you do see things such as the city. We can see the urban heat island of Sydney. We can see the Blue Mountains and the Great Dividing Range and its impacts on temperature. And indeed, you can even see, even though this is 10 kilometres resolution, the urban heat island that's reflected from Newcastle and the port of Newcastle. You can also see the coast, and you can see the clear delineation between land and ocean. It just so happens here that the grid spacing goes straight through Sydney. So half of Sydney's in the ocean and half of Sydney's not. At finer resolutions, we overcome that. We actually start to see the coast. Now, this is very important for us in Australia. The vast majority of our population, 80% or so, live within 50 kilometres of the coast. All of our major cities are coastal cities. We need to have fine resolution data that adequately models those changes at the coastal interface. And indeed, some of those coastal cities, such as Sydney or Brisbane, indeed Hobart, have complex topography around them as well. So we really need that fine scale information. And this shows out critically when we look at an area such as southeastern Queensland. Just this final example, just to really bring it home why we need the local information and what additional benefit we get from the local information, is if you look at, this is change in rainfall, projected change in rainfall. On the left, you have the global climate model. On the right, you have our regional climate model. This is taking the global climate model on the left and running it through our regional climate model on the right. So enhancing the data out of the GCM. What you'll note is I'm going to focus on southeastern Queensland and northeastern New South Wales. If you look at the GCM and you are projecting change in this area, you are projecting a drying. But that's a consequence of the model configuration of the GCM and the fact that we're working and looking at a coastal environment. If you look through the RCM, you don't see any, on the GCM, you don't see any of the detail from the Great Dividing Range. If you look at the coast, if you look at the RCM, we see this resolved explicitly. You see the coastal interface between the ocean and the land, and orographic rainfall that is a consequence. You see drying happening along the Great Dividing Range, but here in southeastern Queensland, northeastern New South Wales, you see some significant wetting. That is the opposite of what the GCM is seeing. And you see a little bit hint of that if you look over here on the far right of the RCM model. In reality, this GCM is thinking that this part of the world is part of the Coral Sea, whereas the RCM corrects that and we understand better that coastal interface. So that's how we model the future climate. We take the outcomes of global climate models and we run them through finer resolution regional climate models. I mentioned that temperatures have already increased 1 degree since the 1950s in Victoria. What we are seeing through the VCP19 projections is a potential of an additional up to 4.7 degrees increase by the 2090s for the RCP 8.5 scenario. So significant increases in temperature well beyond what we've experienced to date. And it really doesn't matter what emission scenario you're looking at. We have increased temperatures built in. So here what we're looking at is decadal changes in temperature, or 20-year changes in temperature, and looking at the baseline period that was used for the study, 1985 to 2005. And that's the blue line here from the observations. And if you take these 20-year periods from 2020 to 2040, 2040 to 2060, 2060 to 2080, each of them we're seeing increasing temperatures, even in the hopeful or best case RCP 2.6 scenario. And this is what we mean by when we're saying there is locked in warming. We know that warming will continue regardless of the scenarios that we choose, in particular over the rest of this century. I do want to take a note here on the upcoming 20 to 30 years, and note also for your decision making when you're looking at what data to use and how to use it, it does not really matter what emission scenario that you're looking at over the next 20 to 30 years. They overlap each other. It's only when you're moving further out, so planning out into the next century, that you need to really consider those other emission scenarios in fine detail. And there's more information about how to make those choices, both on the DELP website for VCP19 and in the technical report, but also on the New South Wales Government's Adapt New South Wales website as well. I just want to touch a little bit on temperature extremes and what we've seen. This is data from New South Wales, and my apologies that I haven't changed this, but I do have the numbers for Mildura. We've modelled real changes, significant changes in extreme temperatures in northwestern New South Wales, such that by about 2070, we expect that 120 days each year will be above 35 degrees Celsius, a third of the year above 35 degrees Celsius. That's a challenging environment, not just for the natural environment, but for the people who are living out in northwestern New South Wales. Reflecting back, the period October 2018 to March 2019 at Bourke, which is in this area, we saw 107 days above 35 degrees and 100 days in a row above 30 degrees. Now, this is just a single summer. But what we're seeing in what was some of the hottest periods that we've experienced in that part of the world, a climate that people found quite astounding, is the climate norm, potentially, by 2070. And the numbers for Mildura are similar, but a little bit lower. In Mildura, potentially by the 2070s, you're expecting to see somewhere in the order of 60 days per year above 35 degrees Celsius. Going back to this period, October 2018 to March 2019, there were 56 days. So we are able to conceptualize what the normal climate may look like in these future changes. The extreme climates that we've experienced over the past few years with extreme heat, they will be closer to the climatic norm as we get towards the end of the century, unless there's significant reductions in greenhouse gas emissions globally. And why does heat matter and heat waves matter? Well, heat waves kill more people in Australia than all natural hazards combined. There are quotes that say that heat waves are the greatest natural hazard in Australia, and indeed in Victoria, there was work leading the way on this after the disastrous Black Saturday bushfires, where work suggested that more people died from the heat wave prior to the fires than actually in the fires themselves. I would actually suggest that air pollution may be one of the greatest natural hazards that we face in Australia. We know that just in the four cities of Sydney, Melbourne, Brisbane and Perth, we see somewhere in the order of 1,500 attributable deaths, so premature deaths from particle pollution, from air pollution each year. That's an astounding number. It's in the same order of magnitude as the road toll, and we spend an inordinate amount of money trying to bring the road toll down. And it's something that we should be doing with air pollution. But this is where we start to think about the benefits of action when it comes to mitigation, because if we deal with reduced greenhouse gas emissions as part of our net zero plans or net zero strategies or our approaches to achieving our net zero targets, we can, and indeed we will, bring down air pollution as a consequence. I just want to touch a little bit back on changes in extreme precipitation, and we can see some of the fine detail and changes that we're likely to see in the future across southeastern Australia. And it is this extreme changes in extreme that the climate models allow us to understand when we look through the modelling systems. This data is freely available on our website in New South Wales, but also indeed through data from other sources as well. what we know about extremes is extremes will change, and they'll change in the future based on the modelling that we've seen, and there will be some significant changes. What I wanted to do is I wanted to take that final tenet that I had speaking about air pollution and think a little bit more about how we can integrate that into what we do in the future. These are emissions in New South Wales, and they're very similar when we look at Victoria, and the trajectory of greenhouse gas emissions over time. And what we can see is we can see some areas where there have been some significant changes, in particular in waste, but also in stationary energy. And that's interesting when we think about how much talk and discussion there is about changes to energy and our energy mix, about the phasing out of coal and other fossil fuel stations. There has to date not been as much emphasis on transport, although I do know that things are heating up in this area, in particular regarding electric vehicle uptakes or hybrid electric vehicle uptakes. But there are some when we tackle and continue to tackle emissions reduction in sectors such as transport and stationary energy. I'm just going to touch on those. I want to look at our electricity mix, and what we have here is the emissions intensity from grid electricity that's forecast out over the next 20 years. And what you can see is, rightly so at the moment, we are lambasted for having some of the most greenhouse intensity grid electricity in the world. But we are on a sustained downward trajectory. And this trajectory will continue because the market has spoken. Lots of support has been put in place for lots of alternatives for power within our markets across the national electricity market. But also reality and practicality has set in as well. And that's because the stations that generate our electricity, that burn fossil fuels, are scheduled to close and indeed have been announced for closure across much of the NEM. If I focus on New South Wales as an example, we see a massive drop-off from 2034 onwards as the largest coal-fired power station in Australia, Eraring, and I think the second or third largest Bayswater, phase out and close down over this period of time, which leads New South Wales grid intensity down at about 0.1 tonnes per megawatt hour. Still a bit to go, left with one coal-fired power station here, Mount Piper, which will shut down in the 2040s. But all of these remaining power stations in Victoria and Queensland, they will close as well. And what that means in practical terms is that for New South Wales, by 2036, 82% of our electricity will be generated through renewable sources, at least, and possibly more. And this is an artifact of the market. The market has spoken and emissions will be going down. And that's important across multiple areas because emissions from coal-fired power stations cause premature deaths. And we know that from our detailed modelling in Sydney, and these numbers will be similar for Melbourne, we know that we can count these deaths and they're not insignificant. Each and every year, we can attribute around 68 deaths in the greater metropolitan region of New South Wales to air pollution, just the PM2.5 air pollution from coal-fired power stations. So moving to that renewable energy focus will actually save lives as we drive down air pollution levels as well. And that's an important thing for us to focus on, that need to seek out other benefits and co-benefits from moving to cleaner production. It will also lead to some significant benefits, hopefully, if we can do better at planning our cities. And going back to heat waves, if we look at the 2011 heat wave in Sydney, we saw around about 100 attributable premature deaths to that heat wave over a period of 1 week in Sydney. That's a sizable number. If we go back and look at just the direct fatalities from the Black Summer disaster, this is approximately 3 times that number, leaving aside the impacts of smoke and smoke deaths, which were sizable. So heat waves, we can focus on heat waves and reducing heat in our cities to save lives. And there are things that we can do that benefit air pollution and the climate and our capacity to live in urban environments that provide more livable spaces for us. And what we've done is we can map out in great detail the hotspots, the urban heat island effects down at sometimes less than a couple of meters resolution. And that can help us to target our environmental plannings or our carbon plannings, or indeed even just plannings for amenity, so that they can deliver multiple outcomes. They're not just sequestering carbon, but they're also acting to alter the local environment and to reduce heat. And this is what we see in Sydney at the moment. Now, of course, in Melbourne, we have worked very hard, and hats off to RMIT in particular and the Call Hub here, to put together similar approaches across 3 cities. So this data that I showed you for Sydney is also available for Melbourne from the DELP MapShare portal. And here you can access data that shows what the urban heat island effect is in Melbourne at fine detail, what the vegetation cover and urban canopy cover is, and also the vulnerability. So how vulnerable communities are to heat. And that's what I've put up here. Now, this is at SA1 level, but it is available at finer resolution as well. So please go to the website, have a look and have an explore through the Web Explorer in your suburb, in your local government area, indeed in your region, and try to understand a bit more what the urban heat vulnerability is at the moment in your city. Of course, that's for now. What about the future? And here I just wanted to highlight an approach that we've taken in Sydney, where we've actually taken into account how the city will grow over the next 15 to 20 years. This is work that we did in the mid 2010s. And what we did is we mapped out, through working with our planning partners, what the different changes in land use would be across the Sydney Basin. Because we know that the city influences local climate. Indeed, it's because we have the city that we have things such as urban heat islands. So when we're looking into the future, we need to be able to inform our planning decisions by taking account of this change in the form of the city and inferring the changes that will induce in the urban heat island on top of changes that we see from climate change. And what we did when we did this modelling at 1 kilometre resolution across the Sydney region is we saw some really interesting and significant things. And that is that there is additional heat within the city that's due to our changing landform. We see that the urban heat island will not just be enhanced by climate change, but the urban heat island will be enhanced by the changes in our city form if we continue to develop the city in the way and in the manner that we have developed it in the past. But of course, those changes aren't uniform as well. So on the right-hand side with this map, you'll see our 2 really big growth areas in Sydney, the Northern Growth Area and the Northwestern Sydney Growth Area and the Southwestern Sydney Growth Area. And you see some significant increases in the urban heat island there in those 2 parts of the city. Interestingly, these influence the sea breeze circulation. And it means that late in the afternoon, in the early evening, it's actually a little bit cooler along the coast. So quite a perverse outcome, and something that caused us a little bit of a surprise when we first looked at this. But the important message here is we need to take it into account what the change in urban form will be with climate change and how that will impact our heat waves and how we live in our cities. Now, I'm just going to finish off with a couple of things, which is to touch on things such as electric vehicles. We know that electric vehicles have great impacts on we know that internal combustion vehicles have great impacts on our health. But we also know that moving to electrical vehicles gives us multiple benefits. And one of those clear benefits is reduced air pollution, and we can monetize those benefits. And through detailed modelling, we have done that in New South Wales. And just to wrap up, I really wanted to focus on, in bringing all of these things together, the need to have fine scale information. We call it situational awareness. We need to have really enhance situational awareness of our local climate and how our changes and decisions that we make in tackling climate change actually lead to the best outcomes for our local population, at local levels for our populations, for our communities. We do not want a repeat of diesel and Dieselgate. And what we do is we look at fine scale emissions to do that. And we model our emissions through very complex systems, looking at multiple data sources, and we do it at fine temporal resolution. Now, with this information, we're able to make informed decisions. Think about overlaying all of this information about how transport changes over time, about how our use of wood heaters, which is the left-hand side, it's emissions primarily from wood heaters, but also from business, and how they change over time, and how we can build better futures by not just tackling climate change, and not just tackling things at what are larger macro regional levels, but really focusing in on the fine local level to be able to get the best outcomes for us. And I'm just going to finish off with one final thing, which is it's our role to look at assets and to manage those assets, not just for now and for the future. The New South Wales government holds $400 billion of assets. And these are the assets that we're trying to protect, to harden, to build resilience in. These are the assets that help us to live our daily lives. And they're assets that are run by the states. And indeed, the states hold the vast bulk of assets. And it's the states who need the information to be able to build our resilience, to be able to ensure that the climate, the local climates that we're designing at the moment are such that they're minimising our impacts on service delivery and human health. And those impacts are occurring right now across the board. So with that, I'm just going to finish off with one final thing, which is we've tried to pull all of this together into a conceptual framework about how we can manage not just the driving forces that are affecting the changes and large changes that we're seeing in our cities and in our emissions and our energy systems, the changes that are leading to ecological pressures and changes in our environments, in the state of our environment, and also leading back into changes on human health and well-being. And think of this as a framework where we have feedback amongst all of the systems. And I know that Angie will talk now a bit about how Victoria is actioning many of the aspects of this type of framework in the way that that you're handling climate change and human health in Victoria. So with that, I thank you.
Thank you, Matt. That was a really fantastic presentation and certainly provides a very compelling argument for our regional model so that we can get that fine scale resolution and be able to use the predictions to build in resilience in our health services and building in green cover in our cities. It was really fantastic. So with that, I'll hand over to Angie to give her presentation as well. Thank you.
It's great to be here, and thanks very much to the EPA for inviting me to come and talk to you guys today. Before I go any further, I would like to acknowledge the traditional custodians of the lands on which we're meeting today and pay my respects to elders past, present and emerging, and really I'd like to acknowledge the deep connection that First Nations people have to the land, the sea and the community. Matt has done a great introduction and there's a lot of stuff that I won't repeat, but I will start off with a little bit of scene setting. I'm then going to talk more about what the health effects of climate change are as we understand them, and then really go into what can we do about that and what are the benefits of action to both adapt and to mitigate climate change. And talk a little bit about what we're doing in Victoria and what the health sector particularly is doing. And I'd also, again, before I go into the meat of this, really just acknowledge the tremendous work that everybody has been doing over the last nearly 18 months in relation to COVID-19. It has been a massive endeavour by people from all parts of the community and all parts of the professions. And I just wanted to say a big thank you to everybody for everything that they have done so far, and to obviously keep it up because we're not through it yet. And I think that's another thing I will touch on towards the end of my talk is what can we learn from our response to COVID-19 and how can we apply that to climate change. So in terms of scene setting, the term the Great Acceleration has been around, I think, since 2004 now, but I still really like it because for me it shows very clearly how these really significant, dramatic and fast changes in socioeconomic trends on the left have been have coexisted or have, you know, in fact probably caused these earth system trends on the right, and it seems very clear that human endeavors to improve our lot have had significant impacts on the earth, and many people use evidence like this to advocate really that we have entered a new geological era, the Anthropocene. And I think it's worth noting that, of course, there have been huge benefits to health as a result of some of these changes in socioeconomic trends in lifting people out of poverty, but also some pretty significant negative health impacts if we think about how we've changed our energy use, not using our own internal intrinsic energy to move ourselves around now, for example, but relying on external sources of energy, and the impacts that that's having on things like obesity and other non-communicable diseases such as cancer and cardiovascular disease. And of course, the other thing is that these great improvements in our socioeconomic well-being have had these impacts on earth system trends, and that is a feedback loop back to our own health, because our health is so very intimately linked to the environment around us, as I'll talk more about. So again, a bit of a scene setting. I also really like the work that's been done by the Stockholm Resilience Centre about the 9 planetary boundaries. And I find this useful to put climate change into context, to remember that climate change is not the only environmental existential threat that we are facing, that we are also overreaching, particularly if you're thinking about biosphere integrity and biodiversity, and some of those biogeochemical flows around nitrogen, phosphorus related to the way our industry and agriculture is being run. I think the other thing that I find useful about looking at this diagram is reminding myself that stratospheric ozone depletion was a big challenge, and we are now in the safe area, and that is testament to all the work that was done around the Montreal Protocol, and I guess a demonstration that when we work collectively, we can actually make changes. So it's not, all is not lost. Sometimes we can get into a bit of a mindset that climate change is this huge thing that is just impossible for us to manage. So I think that's a useful reminder. Moving on, another person's work who I really admire is Kate Raworth. She calls herself a renegade economist. She's from Oxford in the UK, used to work for Oxfam. And she's taken the work of the Stockholm Centre and reminded us that it's not just about us overreaching our resources. It's also about making sure that the resources that we do have on the planet are equitably used to create this social foundation, and that's the inner ring. So what she's describing is the donut, and she says, you know, very clearly she wished she hadn't called it the donut, because from a health perspective we probably don't want to keep emphasizing donuts unless you're talking about zero COVID transmission or the donut economics. And certainly that donut is really showing us that there is a safe and just space for humanity. And that figure on the left is a version of the donut that has been created by Regen Melbourne. Kate was speaking, I believe it was just last week, about how we could apply these principles in Melbourne. And I really like the addition that has been added here to recognise the First Nations healing and reconnecting to country and each other, and that very clear link between the social foundation and not overreaching our ecological ceiling. On the right-hand side of that graph is a bit of work that was done now a few years ago, but basically maps countries against the biophysical boundaries transgressed and the social thresholds achieved. And you can see that up there in the top left-hand corner, humanity sweet spot, that's where we want to be, where we've got the most social thresholds achieved, but the least biophysical boundaries transgressed. And you can see that really there's a little blue dot there that's probably the one that's closest to reaching that, and that's Vietnam. If you look at Australia and the UK, we're doing pretty well from those social thresholds, but we're doing really badly from biophysical boundaries transgressed. So I won't go into a lot of detail here because Matt has so very ably described some of the climate modelling, but these are some of the graphs from Victoria's climate science report. And it's just a reminder to show us that we're already tracking towards the upper limit of projections for observed temperature in Victoria, and we're also tracking to the drier end of winter rainfall in Victoria. And there's that little infographic on the right-hand side, just showing us what we might expect by 2050 under a high emissions scenario. So all the things that Matt was talking about a decline in cool season rainfall, more intense downfalls, sea level rise, doubling of the number of very hot days, many more high fire danger days, and an average annual temperature increase. So one of the things I really wanted to really be clear about is that people often think about health as healthcare, and they think about all of the hospitals and GPs and pharmacies, and the great advances that there have been in that area in terms of medical care. But what we sometimes forget is those other kind of upstream determinants of health, and the environment is a hugely important determinant of our health. If you just look at some of those things from the Sustainable Development Goals there, this isn't just an infographic from PAHO, which is part of the World Health Organization, indicating various environmental factors that affect our health: clean water, energy, our cities, just as Matt was talking about, responsible consumption and production, and of course climate action. What I would also note though is not just our physical environment that is a huge determinant on our health, it's also things like our social environment, our cultural environment, our commercial environment, our economic environment. These are all very important. And if there's been various estimates to try to think about, well, what proportion of our health is determined by these factors, and it usually ranges between about 10 and 40%. Obviously devil in the detail on how you actually do those calculations. Moving on to climate change, the framework that Matt showed earlier on, the DPSIA-based framework, is a really useful approach. This is one that has been adapted from one of the Lancet commissions. So the medical journal, The Lancet, has been a really huge advocate of the health sector's role in climate change, both raising awareness about the impacts, but also what the health sector can do. I like this infographic really because it helps us see that the direct effects of climate change also influence the indirect effects of climate change and the social determinants of health. And that leads to a whole range of health impacts. And those health impacts are both physical and they're also mental. We know that the health effects are going to affect the most vulnerable first and worst, and we know that these health impacts are happening now. So there's often a feeling, we can kind of comfort ourselves that perhaps climate change is going to affect those other people over there at some point in the future, and it isn't something that we need to deal with now. And I'm really hoping that between Matt and I, we will be convincing you that we really do need to be doing something now, that the impacts are being felt locally, and action is urgent. So what I thought I would do is just briefly go through a few examples just to try to make this a little bit more real before going into more of a conversation about what we do about all of this. So I think everybody listening to this will be aware that heat affects health. There have been enough heat waves you know, in Australia, but also internationally, where there have been very significant physical health impacts. So people are quite familiar with the idea that there are physical health impacts. It's difficult to actually identify which deaths are directly caused by heat. So often what we use is all-cause mortality or all-cause admissions to hospital to really understand the impact, because whilst there are clear heat-related illnesses like heat stroke, heat cramps, heat exhaustion, we also know that pre-existing disease is exacerbated by heat. And so looking at all cause is a far better way of actually understanding what the impact is. What a newish element of research now is really also trying to understand the mental health impacts, and there certainly is growing evidence to show that there is an increase in psychiatric mortality and morbidity in relation to heat, and also an increase in suicides in heat. But I wanted to also just show you that this graph that you can see from one of Gasparini's papers of Melbourne, and this is basically modelled relative risk of all-cause death against temperature, and that's average daily temperature over this period of time of 1988 to 2009. And the line graph there, you can see there's essentially a flattened U-shaped curve that at the extremes of temperature, you get an increased risk in all-cause mortality. What might be a surprise to some people on the call here is that there's an increase in cold in Melbourne as well. We often only very much focus on heat. The other thing that I think is worth remembering also is to look at that histogram at the bottom, which is the number of days at those temperatures. And the point that's really important for me to get across is that whilst the extremes, the relative risk of death is much higher at the extremes, those extremes are actually very rare. Looking at quite moderate temperatures of cold and heat, there is still an increase in the relative risk of death, but the number of days at those moderate temperatures are much more frequent. So what that is telling me in terms of the absolute numbers of deaths, the absolute numbers of deaths are greater at moderate temperatures than they are at extremes. I'm not trying to make the point that we shouldn't worry about heat waves. I'm not trying to make the point that we shouldn't be doing warnings about heat waves, but what is important for me to get across is that even moderate changes and moderate increases is important, so that we do need to look out for our vulnerable, and we do need to think about all of the actions that we can do to make ourselves more resilient to heat before we get to a heat wave will have health impacts. Looking then down on that kind of column of other impacts that you might think about to do with heat, I don't have time to go into all of them, but I'm hoping that they may prompt some thoughts for you about what the broader impacts of heat are for health beyond just the heat stroke that we think about in heat waves. So we know, for example, that pathogens are more of an issue in hot temperatures. They multiply more frequently, so in water or food. But we also know that animals who are more stressed during heat waves shed more pathogens as well, and there's greater risk there. And we know that heat will have impacts on social determinants, so that if you are poorer, you may find it harder to actually cool your home, or if you're older, for example, and you may not be able to get up to actually change the setting on your air conditioner, you may not have an air conditioner. Housing is also relevant from that space. Occupational safety is a big issue if we're thinking about labourers in high temperatures and the risks to them, and the impacts on livelihood and productivity, and of course so health and emergency service demand. And as Matt picked up, we have good evidence that there were many more deaths from heat prior to the Black Saturday bushfires than there were the fires themselves, and a significant increase in the attendances to emergency departments, that particularly in those who are aged over 75. So heat again will affect people more at the extremes of age and those who are more socioeconomically vulnerable. So moving on to talk about bushfires, again, We've already touched on the impact of the Black Summer bushfires that I think really were quite unprecedented, but are obviously something that we're going to have to think about more and more in the future. We know that the return period for fires is getting much shorter, and we know that, you know, mutual aid from other parts of the world is going to become harder as their fire seasons extend. So in terms of numbers of deaths, I understand that there were 33 direct deaths from the Black Summer bushfires, but at least 400 excess deaths from the smoke. And the smoke not only blanketed the areas where the fire was, but we'll all remember the images of Melbourne and other cities being, you know, blanketed in smoke, and you know, New Zealand and Latin America even picking up the effects of the smoke from Southeast Australia from those bushfires. And of course, I believe 2,500 homes were lost, and that has huge impacts on both the physical and mental welfare of the people involved. And I understand up to 3 billion animals were either killed or displaced. So really shocking. So, you know, obviously physical, direct and indirect physical and mental health impacts from fire. What is also not perhaps so well understood is that fires also have a very big impact on our water supply, our drinking water supply, and that was something I hadn't really understood until I came to Australia. That issues to do with ash and runoff can mean that the source water for our drinking water deteriorates, and it's sometimes the case that that firefighting agencies need to use water, have such a demand for water that water treatment has to be bypassed. So bushfires are a really significant issue for our water utilities. And of course, all of those other social determinants again apply to bushfires. I've started to touch on. Moving on to floods. Now, floods is something I have had huge amounts of experience from coming from the UK. As one of my US colleagues would say, UK is a very floody country. And I've done a fair amount of work, particularly trying to understand the mental health impacts of floods. And certainly we've done a number of cohort studies in the UK following people after some very significant flooding in 2013, where 30,000 homes were damaged and people were displaced for up to a year, or in fact, the median period of displacement was a year. And there were significant increases in depression and anxiety and post-traumatic stress disorder from that experience, and at levels that were actually similar to levels from terrorist attacks. So it's not insubstantial at all. The fact that people have to face losing their home, their possessions, potentially the lives and loved ones, and also this sort of sense of a change in expectation of the way they thought their life was going to continue, and their community disruption is all very, very significant. We don't have huge issues with vector-borne disease in the UK in relation to floods, but we clearly do in Australia. And I wasn't in Australia at the time, but I understand that the 2016 floods were followed by a very big epidemic of Ross River fever. I believe tenfold increase in the number of cases, so about 1,960 cases in 2017. And Ross River fever is a mosquito-borne disease which gives you fever and potentially rash and joint pains, and can take quite a long time to recover from. So again, significant impacts both on people's well-being, but also on their productivity and also health service use. And this is one of the pictures taken by our resident entomologist of the number of mosquitoes that were identified overnight in a trap. So in an average year, you'd pick up 10 to 50 mosquitoes. I believe it was 2016. This is this picture of the bad year of 1,000 to 10,000 mosquitoes. Last one, moving on to drought. So, you know, obviously Australia and Victoria particularly have very clear memories of the Millennium Drought and the impacts that had. And, you know, drought has also physical and mental health impacts. Often these are mediated by things to do with deterioration in those environmental systems that our health relies on, but also on those systems like our livelihoods, tourism, agriculture, etc. Loss of livelihood is a very major determinant of our mental health and well-being. Just touching on a few of the issues that you may see for health in relation to drought. There's a picture of the Murray River there, the algal bloom in 2016, where I believe there was significant impacts both on water utility supply, but also on agriculture and tourism. There's also issues to do with air quality in relation to drought, as many will know, in relation to dust. There are also some very unusual fungal infections that can occur transmitted by dust, not in Australia as yet, but that doesn't mean that that won't happen at some point. And also risks to do with our food supply, that in drought times there is a reduction in both the kind of macronutrients and the micronutrients, and also the potential again for fungal growth creating toxins that can cause damage, mycotoxins that can cause particularly liver damage. And again, food insecurity and the risks to those who are most vulnerable in our community in being able to access food that is both healthy and nutritious and sufficient in quantity. So trying to kind of pull that a little bit together, this is a diagram that's been again around for a while, since 2014, trying to help us think about this systematically. That there are hazards, there are climate hazards that have been very well described, but there are also changes in our exposure, both to emissions, but also that land use change and variation in that. And then this third aspect of vulnerability, and they all come together to help us understand risk and therefore impacts. I would argue that we are not so bad at describing hazards. We are pretty good at describing hazards, though absolutely take Matt's point about the importance of local level data to be able to understand that. I think that we have a lot more work to do in understanding vulnerability and exposure, and therefore being able to explain what impacts are, both at state but also at local level. And I'm really keen to see more work done in that area if possible. This is just a kind of a number of indicators that my team have come up with in one of the bits of guidance I'm going to talk about later, just to try to think about the sorts of data that we might like to use to help us understand and then track changes. It's the key point really is the vulnerability is both a kind of a function of the inherent sensitivity to these risks. And again, you'll see things that are related to extremes of age or, well, existing health conditions or poverty, but also our ability to adapt. And these are adaptive capacity indicators. And the more that some of these sensitivity indicators are quite difficult to tackle, but I think there is real merit in looking at the adaptive capacity indicators and thinking about how we can enhance individual and community and institution adaptive capacity for the changes that are coming. And as Matt's point well made, a certain amount of climate change is locked in already, and we really have to start thinking about how we're going to manage the unavoidable. We also have to think about how we're going to avoid the unmanageable, and that's the bit that I'm going to talk about more now. Is the kind of mitigation elements of these this issue. So this is from the Medical Journal of Australia Lancet Countdown on health, and the Lancet Countdown is a kind of international collaboration of researchers, all trying to use the same indicators across the world to monitor how we're doing against a set number of climate change indicators. They could all be improved, these climate change indicators, but they're what we've got at the moment. And this is just one of those graphs. And again, I won't labour the point because Matt's pretty much covered this, but you can see the grey area shows us that our total carbon dioxide emissions have been increasing year on year globally, well, and in these selected countries. And you can see the carbon intensity of the primary energy supply. And I have to point out that Australia is the grey line at the top, and our carbon intensity over many years has been one of the highest. It's flat, and it's great to see some of those projections that Matt was showing that it will come down, but at the moment we're not doing brilliantly. We can also see that the carbon intensity of the primary energy supply is increasing in certain countries such as China and India, but some countries such as Germany are actually managing to drop that. Moving on to some more of those indicators from the Lancet countdown. This is just a picture of one of the tables showing a summary of Australia's progress on actions that will mitigate climate change, but also have these health co-benefits. If you just look at the indicator name, the second column, and just scan down that'll give you an idea of some of the indicators, and I'm not going to go into detail. But if you look at the last column on the right-hand side, you can see that there's been progress in some of those things, except a couple. One is the phase out of coal. There hasn't been progress, and the other is healthcare sector emissions. And this is, I think this is up to 2016. So probably not reflecting the most recent data, but certainly showing that there is more to do. So picking up on that carbon footprint of health services, it's probably not surprising that carbon emissions from the health sector have been increasing over time. In Australia, if you think about increasing population, increasing older people living with long-term conditions for longer, it is quite challenging in the face of that increasing demand to increase carbon emissions, but it doesn't mean it can't be done. And again, I will talk a little bit about what's been done in the National Health Service in England, where we certainly have shown that we can reduce carbon footprint. So this is a piece of work that was published in 2018, looking at the carbon footprint of healthcare in Australia. And it's estimated that healthcare was attributed 7% of Australia's total carbon emissions were attributable to healthcare. That's a pretty significant whack. And perhaps it's not surprising to think that the majority of that's from hospitals, both public and private, but also pharmaceuticals have a huge carbon footprint. Australia is sitting somewhere in the middle compared to other countries. So the carbon footprint of the UK contributes about 4% to the UK's total carbon emissions. The US, the figure's around 10%. So, and why should we care about the carbon footprint of healthcare? We're doing good, right? We're looking after people. We're caring for them when they're ill. We're the ones who are going to suffer the impacts of climate change. And I think, I have some sympathy with that point of view, but I also think that actually we need to walk the talk as a health sector. We do focus very much on what the health impacts are going to be, but there are many things that we do that we could do in a less carbon intense way. So I think one of the first reasons is that we need to walk the talk. And then for me, the second reason, again, Matt has already touched on this, is that there are enormous health benefits from a transition to lower carbon ways of living. So that, and you can see there in that infographic that's been adapted from something from the British Medical Journal, fewer deaths, less illness, better mental health by a whole range of interventions. And we've talked a little bit about air quality already, but there are also huge benefits from promoting active and public transport, blue and green infrastructure, and dietary changes, particularly increasing the amount of locally produced fruit and vegetables and reducing our food from animal sources. The other reason why we should care really is that I think the community care about this as well. We do know that many these figures are from some research done by Sustainability Victoria, linking climate change and health impacts, and it shows that health is important to many people in the community, but not many of them actually yet understand that climate change is going to have a significant impact on their health. But once it's been explained, the connection is really readily understood. And then people want to know more about what the health impacts are. And there's also, a clear feeling that it's cheaper to act on climate change now than pay the price, both financially, but also in human costs later on. This same piece of research also asked healthcare professionals what they thought about climate change. And whilst, you can imagine that it was probably a fairly selected group of people responding to this research. Many of those respondents, and there were about 800 respondents in Victoria, really very passionately interested in climate change, very worried about its impacts now and in the future, and very much wanting to do more. Both expecting government to do more, but also expecting the sector and their own practice to do more, and a real call for much more continuous professional development in this space as well. And what isn't shown here is also that only a third of health professionals really felt confident to be able to talk to their patients about what climate change meant for them. So that feeds into that real desire and need for better training of health professionals in a curriculum that is already pretty packed. So it's trying to find space both at undergraduate and postgraduate level. So turning now to what Victoria is doing, we're lucky in Victoria. We have a very, very clear authorising environment that doesn't just allow us to act, it requires us to act. And that is under the Climate Change Act. So as many have already said, we have a whole of government emissions reduction to meet net zero emissions by 2050. There are interim emission targets, there's a requirement for a 5-yearly strategy, and there's a requirement for adaptation action plans. And it's quite clear that we all have our part to play in this. You may know that Victoria's climate change strategy was released, I believe it was 2 weeks ago. You can see there the 5-point plan in that in the strategy. It's mostly and rightly focused on mitigation, but there is also an emphasis also on making us climate resilient, again because of all of that climate change that's already been locked in. We've mentioned those targets that will get us to zero by 2050. I would note that whilst they are ambitious and achievable as our interim targets, we will still have quite a long way to go on the other side of 2030. So the sooner we act, the less hard work that's going to be on the other side. One of the great announcements that I think many of us are absolutely thrilled with is that all government operations, including hospitals, will be powered by 100% renewable electricity by 2025. We estimate that that's going to reduce the carbon footprint of the energy component of our public health services by about 80%. Which is great news. And of course, we'll have all of those health benefits that we have talked about. My department, the Department of Health, and the Department of Families, Fairness and Housing, we were used to be combined, and we're still managing ourselves as one sector because there are so many links. Already have a pilot health and human services adaptation action plan, which is out on the web if you wanted to look at it. We were one of the first, us and the water sector did pilots. We now actually have all to do a statutory plan that has to be tabled in Parliament by the 31st of October. So we are one of 7 systems who are producing an adaptation action plan, which is the statutory requirement. That will be out for consultation in June once it's been to Cabinet, and I would urge you all to please engage with the consultation. There'll be workshops and there'll be an Engage Vic survey, because we obviously want to make it as good as we possibly can, and we're very keen particularly to hear about implementation ideas. The other thing that we're doing is obviously contributing to this emissions reduction through the whole of Victorian Government emissions reduction pledges. We have climate change now in our Victorian Public Health and Wellbeing Plan. So again, as part of the Public Health and Wellbeing Act, we are required to have a state public health and wellbeing plan every 4 years. And for the first time in 2019, we put tackling climate change and its impact on health as one of the major focus areas. So putting it up equal to some of those areas that you might think more traditionally are relevant to public health. And of course, they relate. Again, increasing healthy, you can increase healthy eating and reduce carbon emissions and improve health all at the same time. And that's what we're trying to do, is make sure that things are working synergistically, and we're trying to avoid any sort of maladaptations and manage any trade-offs that might arise. So very pleased that we got that into there. The other thing that is in our Public Health and Wellbeing Act is that each local government has to have its own municipal public health and wellbeing plan that has to have regard to the state plan. So of course, climate change is a key element of that too. Councils are in the process, I understand, of preparing their latest public health and wellbeing municipal plans. And this was guidance that was produced last year through 2020, through COVID, with a huge amount of kind of co-design and bottom-up grassroots input from councils. And so there's loads of case studies about what people are doing at local level. And whilst it is targeted to councils, it may well be useful for other organisations and systems to see if there's stuff that they can apply there. To both helping their communities and their institutions adapt, but also mitigate climate change. As part of this work, we've also put a series of animations on our website that you're very welcome to use and share, to try to, in a simple way, explain some of the complexities of actions that people can take. And of course, we are always emphasising the importance of staying aware of risks and impacts, both looking at the Vic Emergency website, looking at the heat health alert system, Melbourne Pollen, and the EPA Airwatch, as Carolyn has already mentioned. We also have masses of educational material that can be used, again, to help people reduce their risk, both, and just some examples there about heat, about, swimming pools, vector-borne disease, food safety, and smoke. Turning to the health services themselves, we have an environmental sustainability strategy that has been written and is being led by our Victorian Health Services Building Authority. That is really trying to look at every element of how carbon is being, carbon and other greenhouse gases are being emitted through the activities of the health service. So looking both at scope 1, at the sort of direct emissions from the use of fossil fuels by the industry, the indirect emissions, and also those indirect emissions that are a consequence but we have less control over, scope 3. One of the key planks of the work that's being done is introducing solar, and there's a big regional solar program, and you can see the map on the right gives you locations where solar has been installed or where solar is in progress. And that image on the left is from Sale Hospital, which we understand to be the biggest solar array on a hospital in Australia. That should be reducing the, I'm just going to look at my figures here because I might get that wrong. We're expecting this to reduce carbon emissions by 13,000 tonnes and save 2.7 million in energy costs each year. So I think it's a really good example of the fact that sustainability doesn't necessarily need to cost money. It can actually save money frequently. And I think one of the barriers that often gets put up is that it's too expensive. That's certainly not what we are finding. Other activity that the team there are doing is very much promoting energy efficiency with, you know, LED lighting, etc., and making sure that any new buildings are built with the 5-star NABERS design to be as energy efficient and resilient as possible. What the team tell me is that since 2017-18, as a result of all of this work, they've reduced by about 50,000 tonnes carbon emissions from the public health sector, and that's about 6%. So that's definitely showing that they're bucking the trend, and they are actually able to save carbon in spite of all of the increasing demand that health services have had. The Victorian Health Service Building Authority is also looking at climate risk assessments and looking at our assets to understand what are the likely risks. They have taken a hopefully worst case scenario, but potentially a real case scenario if we don't actually manage to start reducing our global emissions globally, looking at those direct impacts of the sorts of things that you would expect, but also those indirect impacts. Ambulance Victoria has also been really leading the way. They're one of the first Australian health services to have a climate change action plan, and they've committed to meeting 100% of its electricity needs through renewable sources by 2025 and a net zero by 2045. Turning away now from Victoria and thinking about, well, what's happening more internationally, the WHO produced guidance in October 2020 for climate resilient and environmentally sustainable healthcare facilities. What I really like about this guidance is that, as well as including all the things that you might traditionally think about as being important, like water, sanitation, waste, energy, and infrastructure, they've also really put an emphasis on the health workforce, and again, you know, reflecting what I was saying earlier on, that the importance of having adequate numbers of skilled human resources in the right working conditions who have the knowledge and the capacity to be able to respond to these environmental challenges. So that's reinforcing that again. One of the organisations in the UK called the Centre for Sustainable Healthcare has taken this a step further forward. They have set up something called the Sustainable Specialties Programme, where they actually fund a registrar in each of the major healthcare specialties to lead on work in developing sustainable practice. So there's a green nephrology, so kidney care fellow, there's a green mental health fellow, and that means that you have an advocate in each of the specialties who is really looking at how things can be done differently. And I think that's a model that we should be looking at, not only for medical specialties, but also for nursing, midwifery, all of the allied health professionals, and perhaps also for other sectors too. You may or may not have heard that the NHS, in the middle of the COVID pandemic, declared that it was going to be the world's first net zero health system. And this is a hugely ambitious program. And I understand from my old contacts back in the UK that that they recognise this is a massive challenge, but they're determined to do it. And they're still sort of, you know, making it up as they go along. They don't have all of the answers, but they're really working again in a very collaborative process to look at all ideas for how carbon could be saved from the health service. And you can see that actually there was a sustainable development unit that was focused for over 10 years in driving lower carbon ways of delivering healthcare, and they really had done a significant amount of progress to reduce the carbon footprint. But it does show you that if we want to get to 2050 and zero, there's still a very, very long way to go. And these are projections. And this also shows you how they think they might actually achieve this. And you can see the purple and the yellow are again perhaps those traditional areas of energy and infrastructure and buildings. But what I really think is important again is to emphasize the amount of carbon that they think they could reduce by changing prescribing, the anesthetic gas emissions that are used, shifting to low carbon inhalers, and using nitrous oxide capture and reuse. The other thing from a public health point of view I'm really pleased to see is really thinking about different models of care, about not necessarily requiring everybody to come to hospital. What can you do with telehealth? Looking at other low carbon models of care, and of course reminding people that if people are able to be healthy and stay healthy, they don't need to use healthcare and create healthcare emissions as a result of that. So recognizing the really important element of preventive medicine and reducing health inequalities. There's also been some recent publications that I just thought I would draw your attention to. So the Monash climate change group have produced the handbook on communicating climate change, which is a really valuable resource in trying to get what is sometimes quite complex messages across, and you know, how to get past the kind of the feeling that this is a huge elephant that has to be eaten and we don't know where to start. The Lancet Planetary Health group have just done a special issue showing that the benefits that would happen if we actually made and committed to and stuck to and delivered the nationally determined contributions under the Paris Agreement, that if we actually hit those, they estimate that there would be over 5 million lives saved by changing dietary behaviour. Over 1 million lives saved by those improvements in air quality that Matt was referring to, and over 1 million lives saved by encouraging active exercise, which is also low carbon. So that's also worth a look. There's also been recently published quality criteria for health national adaptation plans that we will obviously have to cross-check our own adaptation plan against and make sure that we are meeting those quality criteria. The Lancet Countdown have also just recently turned what were kind of regular PDF publications and occasional slide sets into a much more interactive set of indicators now. And I would urge you to go and have a look and see how things have changed over time from all of these different elements. And there's a whole range of different indicators. And my dream would be to be able to actually have a set of indicators specific to Victoria that we could you know, use to monitor climate change impacts and risks over time. So, you know, people often say, well, what can we do? And this is perhaps fairly obvious, but I will just briefly mention them. It's obviously about making sure that you understand the risks and the health conditions that are associated with climate change and where to get more information. Advocacy is really important for both the health and the environment sections of the importance of climate change to make sure that we are ready for the future health effects and that we can mitigate and minimize them as much as possible. There's so much that we can all do in our workplaces in terms of, you know, improving energy and water efficiency and procurement, but there's also a huge amounts we can do in our own homes. And again, there's something there about walking the talk. Really important to keep communicating with the public and with colleagues about climate change and health. And as I say, make it your own carbon footprint, which I've already said. And employers too have a role of helping us find ways to take action and reduce our carbon emissions. So I'm coming to the end now, but I just really wanted to reflect a bit on the COVID-19 pandemic and to just think about how much we have all done at state level, but also nationally and globally to respond to an urgent and present threat, which was COVID-19. And, you know, some countries have been more successful than others, but where those countries that have been successful are really where there has been collective understanding of the risks and a collective agreement to act on them, you know, in a systematic way. And I think that is something that we must try to carry through in the way that we're dealing with climate change as well. And, you know, many people feel that however bad COVID-19 has been, climate change, particularly if you're going out to 2050, 2070, is going to be a far bigger threat to human health than COVID-19 was and is, and that's pretty scary. If I'm perfectly honest, I think that that's something that is quite hard to digest, given the year that we've had. But I think it's worth definitely keeping in mind. And as we're coming out of the COVID-19 pandemic, and you know, after every disaster we talk about building back better, it's thinking about how can we make sure that our recovery is as healthy and as low carbon and green as possible. WHO are taking a real lead in this. Dr. Maria Neira is really pushing for these key elements, which you can see there, and I'm not going to read out to you, and are pretty pretty straightforward. So really, I'm just coming to the end of my talk now. But you know, one of the things when I started in this space was that, you know, we would always say climate change has been described as the greatest threat to public health in the 21st century. It came from one of the Lancet commissions, and it was also repeated by the WHO Director General. And I think that still remains the case. But it can be hugely off-putting. It can feel like there is nothing we can do about it, that this is just too huge. And I think it's really important to remember that at the same time, if we tackle climate change in a way that is both healthy but also just, it can also be the greatest global health opportunity too. And I think, you know, there's a huge amount of no regrets actions that we could be taking that are not, you know, expensive, and will lead to a better place and better health for our communities, whether or not climate change happens. This is my last slide, and this image on the right is just a classic public health image of the fact that what we do in public health is we stop people getting ill in the first place, or we stop people getting injured in the first place, so that they don't need healthcare at the bottom of the cliff. So, you know, if we can stop people falling off the edge of the cliff, or we can stop people pushing people off the edge of the cliff, then we will have done our job. So climate change, I genuinely believe it is the defining health issue of the 21st century, that health effects are being felt today. There are huge opportunities, as well as the risks. And we are making progress. It's not all bad news, but we've still got a hell of a long way to go. And I think, you know, it's really important to emphasize that everybody has a role in this, in both reducing climate change, but also supporting our communities to prepare. So I'll stop there and hand you back to Carolyn. Thank you.
Thank you so much, Angie. That was a really terrific presentation, and I wish we were live so that we could all give Matt and yourself a round of applause. If I could just reflect on your presentation, Angie, it was a good reminder, I think, for everybody of what was achieved under the Montreal Convention regarding ozone depletion, and also what's been achieved in some countries in relation to COVID. That change is possible if we work together, and I feel like that sort of optimistic layer we need to build into that to remind everybody that change is possible if we work on large scale and small scale together. I did have one question though, if I can start off the questions. In one of your slides, you had a note that Victorians rank health as their top priority, yet 90% haven't thought about how health is affected by climate change. And I really just found that quite striking and wondered what your thoughts on as to why that is a situation we're in, despite the numerous resources we've got on government websites. Why haven't people made the direct connection between climate change and health?
Yeah, it's a question I ask myself a lot as well, Carolyn, and I think it goes back to really where Matthew started, to be honest, is that I think climate change is often thought of as an environmental issue. And I think people don't have, not a health issue. It's about the polar bears, it's about the loss of the forests and things like that. I think and I think it's also because there isn't a great understanding of how our environment affects our health either. So those two elements, like, I know from just talking to mums at the school gate or hairdressers or whatever, that they really don't see, they see our health as related to healthcare. They're really quite surprised when you talk about actually things to do with, differences in life expectancy depending on where you live or that impact. So I think we have a lot more to do to try to make it clear that about those links. But I'm also open to anybody's, if there are people out there who think, well, why aren't they doing this, that, or the other? I'd be very keen to know about it, because I don't think it's a nut we've really properly cracked yet.
Thanks, Angie. Matt, I'm interested, do you have any perspectives on why that connection between climate change and health hasn't been directly made by segments of the community?
Yeah, I think there's two things, and as Angie, that idea that it's environmental, but it's not about. Worst things that ever happened in this space was images of polar bears on icebergs, because it's never really been about saving the environment. It's about saving us. But the other thing that I'd add and so that core narrative was never there. It was always a core narrative about the environment and polar bears and the like. But also the other thing is the visibility. I like your intro, Carolyn, where you mentioned the improvements that we've made globally through the Montreal Protocol and the way that we've pulled together with COVID. But actually, you can go back, and this is where air quality provides another good a good lesson for us. The 1950s and 60s, Western societies, across the board, Europe, North America, here in Australia, were facing some significant urban air quality issues. And you think about the London smogs of the 1950s. Indeed, when the ozone issues first became obvious in California and here in Sydney, giving an Australian perspective, these were things that people could see, and that meant that people would act. And it's the same thing with COVID. We could see the images out of China, and we didn't want to have them reflected here, so people acted. Climate change isn't quite the same. It's why we get that visceral reaction when we have things such as the Black Summer bushfires or a flood or a cyclone. We can see these things, but we're not really showing people. And Angie actually mentioned, no one comes with the very rare exception of direct impacts from heat exhaustion and other things. No one really comes with a death certificate that says climate change related heat death or climate change related air pollution death. We know they occur, but they're hidden. And I think part of what we have to do is resurface those impacts, so that people actually see that these are impacts now. We may not be able to visualize it outside of natural disasters, but we can see it in the way we report about it. And I like some of the measures that Victoria's got in reporting sort of progress or exposure, because I think that's one of the ways to do it. We're all very much attuned to the road toll. the annual road toll and how many people die on our roads, we should be thinking about something in a similar vein with the impact of climate-related hazards, climate change, air pollution. How many people are we attributing each and every year to these things? And then it becomes visible, and then people start to care a bit more because they can see it and they can understand it.
Thanks, Matt. I agree with you there. And we've got some questions coming in now from the audience. And one of these relates to this discussion. It's a question from Liz. It's for you, Matt. I think, what are the locations in the world that currently experience the climate forecasted in 2070 for Mildura and Bourke, Sydney and Melbourne? And this might help people relate to the shifts in temperature.
So, yeah, not too many. There's a great climate analogues feature on the Climate Change in Australia website, where you can sit there and you can look to see what are the closest climate analogues for futures. So, jump on the website and have a look at that. Not having that right at the tip of my fingers at the moment, but I would suggest somewhere like Mildura, you're talking then about, areas in the northwest, Karratha and places like that as the move. So it's no longer the Mildura, it's more of, the context of Karratha or Marble Bar or places like that, places that really experience really extended lengths of heat. 120 days a year over 35, that's a fair whack. Other than that, there's very uninhabited parts of the world, in particular in Iran, central Iran, and in parts of the Sahara. But again, I don't want to say too much. Jump on the Climate Change in Australia website and have a look at that climate analogues tool, and you can have an explore for yourself. It's a great tool.
Thanks, Matt. A question for both from Stefan. There are lots of great clear behaviour change actions at local government and individuals can take to increase adaptive capacity and reduce harm in the materials you shared. Do we know if any of these are working? Maybe a question for you, Angie.
Yeah, it's a great question as well. We don't know. The simple answer is that we don't know, because we don't often evaluate very well, or if we do evaluate, we don't share those things very well. So I think that we could say that they are all things that are plausible, very plausible as having an impact, but whether or not we actually have good, strong evidence for a lot of them, particularly at local level, I don't think that's the case. There is plenty of research, again, looking at a lot of the Lancet Commission work, looking at kind of the macro scale about if you reduce air pollution, you will get this. If you increase activity by this amount, you will get that. But then translating that to the local level and understanding the impact, I would say is difficult, and we probably don't know. But Matt, you might have further thoughts about that.
No, similar thoughts, Angie, and actually, a very big promoter of the need to do comprehensive evaluation of government programs and intervention. I actually think it's an area where we as a broader community can learn from the health sector. The health sector actually, in clinical interventions, does a really good job at evaluating the outcomes of different interventions programmatically and with great specifics. I think probably what we need to do is we need to port that approach very much across into the public health space and into this climate change intervention space, indeed into the general livability space, and bring some of the rigour that's been learned from evaluating those clinical interventions over into the public health space. But often what we're faced with is the challenges of that is costly. But we as researchers, as governments who are funding programs and indeed delivering our own programs, we need to make sure that we build that evidence base by putting aside sufficient evaluation component to be able to do this. And I'm happy to say that in New South Wales, we do that now. All of the programs that are funded out of our climate change fund have to adhere to our detailed evaluation framework. Now, of course, that doesn't give us the evidence that we need right here and now. This generally takes a few years' time. But if we all commit to doing something similar to that, then we know that we'll get the evidence that will support us to design better interventions, pick out the ones that are giving us best impact, or indeed make some changes to our programs so that we get optimal outcomes. But it's certainly a good question. It's something that we need to focus on.
Yeah, thanks, Matt. There's two questions here that I might roll into one for you, Matt. The first part is, what's stopping us going even finer with our global climate models? Why not 1 kilometre? And then as a related question, what or when is the point where better regional modelling and predictions representing diminishing returns of value for effort in preventing harm, and have we reached it yet?
So I'll take the first one, which is what's stopping us is basically computational power. We're already running like the finest scale Earth system models are running on the biggest supercomputers in the world. They take a long time to run. Even our small regional climate modelling projects like NARCLIM, it basically took us in the order of 4 million CPU hours and generates petabytes of data. So huge amounts of data. Think about, so our NARCLIM regional climate model generated about 4 petabytes of data. So think about a 4 terabyte external hard drive, equivalent of 1,000 of them. It's literally a truckload of data. If you drove up a truck and put them in, that's how big it is. And then 4 million CPU hours, even on the fastest supercomputers around, you're talking about months and months of computers running at their full capacity. So it takes a lot to be able to do that. Now, as we see improvements in computing and indeed potentially using GPU processors, then hopefully we'll start to see finer and finer scale models. The second one about have we extinguished it? No, I don't believe so. Regional climate modelling really as it stands at the moment is an intermediary step. When we get our big Earth system models running at finer and finer resolution, and we have complete Earth system modelling within one modelling system down to sort of a kilometre resolution or even less than that, then we won't need the regional climate modelling approach, that intermediate step. So ultimately everything, whether it's the carbon cycle, local air pollutant emissions, local energy energy emissions, is held within one modelling system, and we're not cobbling things together. So until we get to that sort of regional scale Earth system modelling, no, we're not exhausted yet.
Thanks, Matt. A question for Angie from Milana. Population and climate change are inherently linked. Perhaps it is outside the scope of this discussion, though. I'm wondering how the impact of climate change on public health will impact global reproduction rates, and is that impact modelled in global climate models?
So yes, it's you're absolutely right, Alana, that population is a significant influencer on the amount of carbon that is being produced. But it's more to do with how those individuals are behaving than the total numbers. So those most populous countries, like India, for example, or Africa, the per capita carbon emissions are much lower than the per capita emissions, for example, of an average Australian. So I think that's the first thing to say. I think the second thing to say is that as countries do get wealthier, people produce less children because they have a greater chance of survival into adulthood. So that, we do see this process of demographic transition as countries become wealthier to come from low income to middle income, that families have fewer children, which is also good. And then I think that the third thing to say is the real importance of the rights of women, and that the sort of gender equality lens in this, and that promoting reproductive rights is really important in managing population, and that if I genuinely believe that is the most most appropriate way of managing the population issues is to really encourage the reproductive rights of women, to enable them to have access to contraception, and also to improve healthcare and the environmental situation that people live in, and the economic situation that people live in, so that their children can survive to adulthood, so there isn't this pressure to have so many children. I do believe that population, certainly in all of our health service planning, we are very much aware of the increased projection in terms of both the size of the population, but also the increased size of the vulnerability, likely vulnerabilities of that population as it gets older, and people, as I said earlier, who have long-term conditions survive for longer as well. So that is all coming into our health service planning. In fact, I would probably say that most of our health service planning is more focused on the population elements and not enough focused on the environmental elements at the moment. And I'd be quite keen, and people know in the department, I'm talking quite actively about how do we bring the two approaches together. So I hope that answers your question.
Thank you.
I might just add, because I think the question also asked about is the population modelling included in the global climate modelling? And yes, it is. So with the latest generation of global climate models, CMIP6, which will come out in the next, are out now, we have representative concentration pathways, RCPs, and shared socioeconomic pathways, SSPs, and population varies across the SSPs. I think I recall that the lowest population growth rates, or the lowest population curves, are in SSP1, all the way through to SSP5, which I think has population peaking at somewhere in the order of 8.5 to 9 billion people, and then declining towards the end of the century, but they are included in the models.
Thank you. And a related question on the models and what's factored in, question from Alistair. Are greenhouse gas emission feedback loops adequately factored into climate models?
A big question and a good question. I think the model developers do their best that they can to be able to get those feedbacks in. Obviously, there's a range of parameterizations and other things that have to occur. I gave an example of clouds and the way that clouds are handled. I mean, one of the big things is ensuring that we get the appropriate feedback loops for clouds, tropospheric clouds, storm clouds, but also upper tropospheric clouds as well. So I would say there's work to be done here. Whether it's adequately factored in, I think's open for a definition of what adequate is. They are factored in. We do a pretty good job. But what we do know is, looking at things such as climate sensitivity, we are narrowing the bound of plausible ranges for climate sensitivity, and there are a range of GCMs, global models that sit within that plausible range, and that would suggest that they are getting those feedbacks reasonably well done. But there's still improvement, as there is in many aspects of global climate modelling.
Okay, thanks, Matt. Question for Angie from Liz. Have you mapped vulnerability to air pollution in the same way as heat?
I haven't personally, but I'm aware that there is work doing to do that. Certainly from the UK, which is where I last worked on air pollution, there was certainly an important piece of work looking at both air quality measures versus the underlying vulnerability of the community.
Okay, thanks, Angie. And this is a question for both from Stefan. What other changes are needed, by whom, where and when, to prevent harm from the climate change impacts we can predict, for example, on the basis of regional climate models? So what other changes are needed, by whom, where and when, to prevent harm from climate change?
Angie, did you want to go first?
No, I thought you could go first on that one.
Yeah, I
that's
think
a big question.
Yeah, that's a big one.
Certainly at the local level. I mean, that old adage that climate change mitigation, thinking about the global level climate change adaptation is local. So I think it all comes down to the biggest changes we can make are really changing our strategic planning and our land use planning, the way we plan our cities and our towns, the way we plan our transport systems and networks, the way we plan the infrastructure that supports the way that we live both now and into the future. And I gave some examples from Sydney where we modelled some of the changes in climate just from changes in landform. I think many jurisdictions, certainly within Australia, are starting to go down this path. We, in 2016, put out our state infrastructure strategy alongside our strategic plan for Sydney and our state transport strategy, future transport. And all three of them use the same common scenarios. And all three of them called out resilience and building resilience, both the short-term weather impacts, which is really our lived experience of climate now, and potential climate change into their strategic planning. But we still have a bit to do. And the next iteration of those top-level strategies in New South Wales are moving closer and closer together. We're having finer interactions regarding the scenario planning that we use, more discussion and dialogue about how best we work together to plan the form of the city so that we're actually not building vulnerability 20 or 30 years in the future now. So I think that's one of the big things that we can do. We often think of cities as static places, but they're not. They're dynamic places. They're changing all the time. And I think if we had a strong strategy in looking towards building livable cities, then we'll go a long way to alleviate some of those risks that we may be exposed to in the upcoming decades.
Matt, if I could ask then as well, so it was a question in relation to your talk where you had the urban heat and green cover maps.
Yeah.
We've got some good take up from government in terms of building design and so on. What about and green cover? What about industry? Have industry been taking up initiatives to reduce heat effects of buildings and green buildings and that kind of thing? Do you see it in private industry as well as government?
Yeah, so there are some leading providers who are really at the cutting edge, looking at green infrastructure, embedding green infrastructure within their built infrastructure. Think about some of the modern architectural features of buildings where you have living walls and living roofs and other things. But I think we're far away from mainstreaming that. They're really still seen as fairly niche things. One thing that I think is an impediment here is, a lot of building is very much codified. And in tighter economic times, we're building to code.
We might have lost.
And might be seen as there's an opportunity for a competitive edge. There's an opportunity for a competitive edge for those companies who want to take that leap forward and go beyond building to code. But also I think we need to strongly look at ratcheting up codes. And making sure that that the Australian building codes actually are reflective of the future climate that we're likely to see. And this is just a point that I'd like to make. We are still building and codifying structures to the past climate. So we're building and designing buildings now that will have lives of 30 to 40 years, and we're basing it on the climate of the past 30 years. Which is not even close to being representative of what we're likely to see over the life of these buildings.
Thank you. Probably got time for one more question. This one's from Ivan for you, Matt. I understand there'll be models from new forcing scenarios being developed for the upcoming IPCC 6th assessment based on shared socioeconomic pathways rather than RCPs. Will impact assessments based on the 4 RCP scenarios be used in the IPCC 5 models need to be redone?
It's a really good question, Ivan. My answer is, possibly, but possibly not. I think one of the messages that we're trying to say as far as impact planning is concerned is, as long as you're thinking about this and asking the questions, you need to ask yourself, that's a good step. You need to ask yourself, what are my likely impacts now? I often say the first thing is, how is the climate impacting me now? And you've probably gone through that approach when you've done your impact assessments now. My next question would be, is there a significant change to what I'd assessed in my current assessment with the release of the CMIP6 models and AR6. And then you just get into that classical risk planning framework. If the risk has changed, whether it's changed because of exposure or vulnerability or other matters, then yes, our advice would be likely go and redo. If it's not changed significantly, then there's probably not much need to do it unless something else changes as things come along. But if resources allow, certainly update them if you can. But our message is take that risk-based approach and assess it for your needs and purposes always.
Thank you. We might wrap up the questions there and thank everybody for submitting such really good questions. If people want further resources, there's information on the Department of Health website, including a report written by our Chief Health Officer on this topic. There's also climate change on the EPA website, Victoria's climate change strategy on the DELP website, and of course the presentations have listed a large number of resources that you can also find when they go up on the EPA website. So I really would like to thank our presenters for such really great presentations today and for stimulating some really good discussion around climate change and health. And as I said earlier, I wish we could give you both a round of applause. So think of it as virtual applause. And we look forward to seeing everybody at our next Environmental Science Series event, which is anticipated for August this year. And thank you to everybody who attended the live and live stream audience today. Thank you.